Okay, go ahead, please.
So hello everyone, I'm so glad you could be here, and we also have another volunteer, so I appreciate your attendance. Okay, so my name is Fu Chen. So I'm a PhD student in electrical and computer engineering, and right now my research topic is about computer vision, and maybe you can say it's the vision of the machine. So I will give you, I won't give you maybe hard technical details. I will give you some very simple examples in your daily life, so they make you understand what is computer vision. So this is my outline. So I will give a brief introduction about this topic, and I will give you some popular application of computer vision, and talk about what is my research, and I'll give some conclusion and maybe the future work about this topic. Okay. So what's a computer vision? So maybe you may think about, you may want to explain this word literally. So think about how to design an eye of a computer or a robot. No, it's not. So this is the eye of the robot, but we will not talk about this. So actually, so what's the computer vision? So it's about how computer could recognize or how they comprehend or analyze the thing it receives. So what's the thing for the computer? So generally it's an image or video. You will record it from a digital camera or from your iPhone or some monitor, something like this. So for example, so it's a very simple example. So okay, this is a picture of an apple. So we will run it on computer and we hope, okay, so computer can recognize it. So computer can say, okay, this is an apple. So it's a very simple example. So it's a this is another example. So for example, in this thing, we may want computer to recognize everything in this thing. So for example, they could see, oh, there's a tree here, and they could recognize, oh, this is the house, and there are cars here, and this is the length of the road, and we maybe want to extract some skeleton or some structure from the scene. So by doing this, the computer could analyze the scene and tell people where is the car, and you can try to avoid, try not to hit the car, or maybe you want to go somewhere, so they will direct you to the correct direction. So this is another example. So it's a pedestrian detection. So it's very popular in some monitoring system, because they want to locate every person in the scene. So maybe if some people have some dangerous activity, or maybe you want to track some person, then the computer could detect them in a very short time. So this thing they could detect each person in the scene, and they even could give you the coordinate, the 3D coordinate of the person. So right now I'm talking about some public application of computer vision. So this is one kind of public application in your digital camera or in your smartphone. This is called image stitching. So this means that you can make a panorama. You take several pictures, and the computer will compute how to link this photo together to merge to a huge panorama. So it's such an entertaining application. So how robots do this? So here to compute the relationship between the two photos. So for example, so these are the similar photo but taken from a different angle. So the computer has to know the correspondence. So have to know this corner belongs to here, maybe this corner belongs to here. So this is another example. So this technique is very useful. So even if the scene are slightly different, so you can see the color and the light is a little different, but the computer could still compute the correspondence correctly. So they can know, okay, maybe the head of this person belongs to this position, and maybe or this corner is also belongs to this position. So after the computer knows the correspondence, then they could merge the image according to the correspondence. So this is an example. So it knows this photo belongs to the left side of this photo, so they could try to merge that to the correct position. So with the merge the photos, the computer will smooth the image to make it look more natural. Okay, this is another application. It's called structure by motion, and I will show you a video. So actually, this is a project I've done in my master's degree. I hope we could. Let's speed up. So it's just a funny project, but I just want to show you an example how this works. So I shoot some 3D object into a thing. And he tried to dodge a bullet. This is it's like a slow motion, big slow motion. Okay. So anyway, I wanted to see, so I insert some 3D object into the scene. So how do I accomplish it? So this is called a technique called structure by motion. So since I have to insert some object into the scene, and the object should be look naturally. So I have to know the real 3D position of the object. For example, I have to know where the floor is and where this person is. So I could plan my trajectory of the bullet correctly. So I have to figure out the 3D structure for some technique. So this is one of the techniques. So for example, there are buildings here, and we take several pictures from any arbitrary position. And so we don't know the exact position of the camera. But after we collect all the picture, we know the picture is providing the same structure. Then we can derive the 3D structure of the building or the person, or any things in the images. So this is one example. So this triangle shape icon means where the photo is to be taken. So after the photo is taken from maybe this so many positions, then they will reconstruct the 3D structure of those building by those photos collected from these kind of positions. So this technique is very useful because for movie industry, you will be able to insert some 3D or some animation into your scenes, so you can know the 3D structure. So another useful application of this technique is for geology or civil engineering, because they want to investigate some structure, or maybe they want to know the structure of the mountain or maybe the bridge by collecting some video from the helicopter. So after you collecting the videos from the helicopter, then you could reconstruct the structure of the building of the mountain by the structure of motion. So you can collect those images from video, then you can really compute the 3D structure of your target. So this is another common application of the computer vision. So it's also in your digital camera or smartphone. So they could tell where the face is. So this kind of technique is somehow harder to accomplish. So in this application, you have to pre-train, you call it detector, to distinguish whether it's face or not. So you may need more than 100,000 face and non-database. And after you collect this, then you will train the detector. So after you have this kind of detector, so for input image, you have to scan among the images to see whether this red flag is belong to face or not. So actually, this is not actually a detector. You can say it's a classifier that could distinguish whether this flag is face or not face. So actually, it's not detected. You have to answer the questions. This flag is face or face, maybe thousands of times. Then you can detect the face in the images. And this is the less popular application I want to mention, so it's called object recognition. So maybe you guys have some experience for taking a face in Facebook. So before you sorry. So you may want to take the name of the face, and Facebook will give you some suggestion, and maybe the suggestion is somehow very accurate, maybe amazing. Or for example, if you want to take this person, maybe he will give you several images, or he will, is this the same person? So actually, this is a technique called face recognition. So it's more advanced than the face detection. So in this application, you only have to detect face. So in this application, you have to detect face first, and then you have to compare the feature between the faces. For example, you can compare the skin color, the position of the face features, something like this. And maybe you may want to generate a 3D structure of the face, and you compare the face of each person and find the most similar one. And this is another example of object recognition. So this app is called CanFind. So which means you can take any picture and it will give you a keyword about your picture. So it's very amazing because I just took a picture about a part of my skirt and put it on my shirt. Sorry. So I can this is a black shirt. So I took this portion of the shirt. And this is my auto key, and this is my USB flash driver. And if you lay out some vendor's text or on the product, they will say, oh, this is a transcend USB flash drive. And he even can look at my cat, or this is a red and black cat. So this is very amazing. So this kind of application, it needs lots of database. So you can extract the features from the image, and it will come back usually database to extract the crucial keywords for your photo. Right, so now return to my research topic. So currently I focus on designing a computer vision algorithm for, it's called a non-destructive testing for monitoring for bridge or buildings. So which means we could use camera or some monitoring digital camera or smartphone to capture the picture of those buildings and to monitor the health status. So it's faster, it's cheaper, safer, and maybe more accurate. So why I say it's safer? Because, for example, this is a picture of a power plant, nuclear power plant. So if you want to see if there is a crack on the wall, so if you have to do it if you have to do it by human, so you have to wear maybe a safe suit, and you have to climb to this building by a rope, and have to collect picture one by one. So it's very time consuming and expensive, and it's very dangerous. So this situation also applies to this kind of bridge. So how could you send people to this position to collect the data from this structure? So if you could collect videos or images remotely, and since there are lots of images, so if we could analyze images by computers, it would be a better and more safer way. So this is one example. So we can detect a crack and try to quantify it. So it also includes the application I mentioned about. So it includes object detection and structure from motion. So this is an example. So we could detect the crack by the red rectangles. And so why do we need a structure from motion? Because when we take the picture, we still don't know the position of the camera. So we don't know the real scale of this crack. But if we could collect this image from different angle or from different position, then we can know the distance from the camera to the crack. Then we could recompute the scale of this kind of crack. So after we detect the crack, then we could try to quantize it. So we share the center line of the crack, maybe we could try to analyze the width of the crack.
Chen, could you please conclude briefly?
Okay. So this is another kind of application. So when we want to inspect the structure, but since the viewing of camera is not big enough, so we have to take several pictures and we will stitch it together. So it's like a panorama in your iPhone. So this is another example. So if we want to detect the defect payment, so we can use a 3D depth sensor like Kinect, and we could detect the holes and the defect in the payment automatically. Okay, so conclusion is so computer memory defect is everywhere in your life. So it's in your smartphone, your camera, in movies, or even Facebook. So there are more kinds of applications that you could expect. So not even in a civil engineering, it will also exist in the geology, culture, aerospace engineering, or industrial engineering. Okay, so I'll conclude. So about the future work, so right now the different applications have their design separately. So maybe somebody could design a real computer vision that could calculate anything. So in one framework, and maybe someday the computer vision could combine with the cloud computing or the artificial intelligence. Okay. So that's my presentation.